So I'll try to kind of, like usual, try to kind of highlight things that are important and things that aren't important. Because now that I know what your test looks like for Friday, right? So, you remember the pillars of creation, the Eagle's Nebula? A lot of stars can be born in kind of one, what we call giant molecular cloud. So we're actually going to see some photos where a bunch of stars are in the process of being born. And actually, a bunch of stars are born together, the same kind of blob nebula. We call those a star cluster. Those could be open clusters or globular clusters, kind of like we talked about in the previous chapter. So most of the space between stars is basically a vacuum. Okay, we call that interstellar space. But if you run into a nebula like this, you could have stars being born. So just like kind of the video talked about, remember the cliff climber, okay, and gravity was kind of bringing the cliff climber down. He dropped his apple. The apple was like history, but he was kind of fighting gravity. Well, actually gravity, like we talked about in the formation of our sun and our solar system, the middle of our solar system, gravity is important to get that pressure and temperature in the core to begin nuclear fusion. So, like I said, oftentimes you could get a bunch of stars being born kind of in the same, what we call giant molecular cloud. It's kind of a little bit of back and forth because as potential energy is converted into thermal energy, because the thing gets smaller, you know, what we call a solar nebula earlier, it's happening to stars all around the universe. Actually, as it gets warmer, then the thing that's getting warmer wants to kind of kick out a little bit. So even before it begins nuclear fusion. So it needs to kind of cool down. It's kind of a little bit back and forth. There's this thing called Jeans instability that needs to be overcome. So the next few slides are going to kind of talk about if you do have kind of this cloud out there that's going to birth a bunch of stars. It starts out like this, and this is what we call kind of just a homogeneous sort of mass. Okay. There needs to be some sort of kind of fragmentation of that cloud that can birth the stars. And that fragmentation can begin with a star blowing up over here. It can also, we can have two clouds kind of collide to kind of begin these sort of little knits that can ultimately become stars. So from the homogeneous kind of no knits to this, okay, these little things can start to form stars. So gravity kind of kicks in after it's got kind of a kick in the butt to start kind of the snowball process, kind of similar to what our star did. So this actually, if it kind of looks like a photo, it is a photo. So you can kind of see the nebula sort of thing going on. Evidently, we have a region in space between stars that does have dust that can form new stars. So if we were to kind of hone in on a region, we would see stars in the process of being born. I'm going to go out and grab I got a photograph of Orion's Nebula. So this looks scary. So this is not what Orion's Nebula looks like in just with your naked eye or through a telescope. Let's see if I can do this. Do this. I guess I want to do, oh, I see. I want to bring in a photo. This is the one I wanted. Okay. So this doesn't look so scary. This right here, okay, is what you were seeing in the red a minute ago. This actually is what you would see through a telescope. The stuff in the red was looking at the same region, not in visible light, but looking at infrared. Okay, so we kind of look at different wavelengths to kind of get a sense for what's going on. And you can see this is actually the sword region. Looks like the three belt stars, but it's not. It's in the sword region. So one of the cool things, I'll do that. I guess I go this way. One of the cool things we have access to is stars being born and stars living in middle age and stars blowing up. So the cool thing is we can see stars at all sorts of different stages in their lives. And so scientists kind of, use that to their advantage. These slides are going to be very similar to when we talked about the chapter on our solar system. Okay, we said that we started out as a solar nebula. Okay, we said conservation of angular momentum. Okay, the little solar nebula had a little bit of spin, and as it kind of got smaller, just like a skater brings in her arms, it went faster and faster. This little nubbin thing in here is going to become our sun, and actually this little nubbin thing in here could become another star. This kind of accretion disk here can become planets around, or become planets in our solar system. It can also become planets around other stars. Okay. So to kind of finish that thought, basically it's the same process that happened in our solar system happening around other stars. Like I said before, we really think that other stars have their own set of planets, which is very cool. And 10 years ago, that may not have been necessarily the case. So early on in the life of a star, we call that star a protostar. And kind of what's being shown down here, this last thing, kind of down the last thing, that's still a protostar. Proto, kind of like a prototype protostar. It doesn't have nuclear fusion going on in its core. You know that, in a sense, because it hasn't, cleared its little accretion disk of the dust there. It hasn't turned on and created, we call it solar wind. I guess they would call that stellar wind. Okay, so we can oftentimes get these jets of formation perpendicular, I guess, to kind of the plane where you might have planets form. So that's kind of what we see here, kind of these jets on either side. And the accretion disk around this particular star would be here. I know it's kind of hard to see. Okay, so this would be kind of its accretion disk, and we have jets going out on either side. So protostar is actually before it really is a star, before it has fusion in its core. Okay, it's nice and toasty, you can have those jets and all that sort of thing. But it's not a star until the first stage of a star is called the main sequence. And we've been talking about main sequence when we looked at HR diagram. It's kind of like that diagonal stars, main sequence stars. And one of the things you're going to want to be able to do for your test is identify what is a main sequence star. And it's up here. Main sequence star is one that is fusing hydrogen in its core. Okay. Hydrogen fusion in the core. I'll go ahead and add core. This semester, that's an R, C-O-R-E. This semester, I'm not emphasizing it, but I'm hoping everybody's on the same thought that only in the core of the sun and only in the core of any star do you have the hot enough conditions, and can you go ahead and have hydrogen bump into other hydrogen and fuse to form helium. So here's the word balances, and actually that is something that we talked about when we talked about our sun. We said our sun is in balance with regard to gravity, okay, and an outgoing pressure from the energy it's creating in the core. So to turn on, if it's an object or star about the same mass as our sun, this kind of coming together through a protostar to a main sequence takes about 30 million years with an M. So kind of from left to right, this looks, again, kind of very similar to kind of the story we talked about, the nebular theory, okay, the solar nebula ultimately becoming our sun and the planets around it. I like the number 4. It says, long-lasting state of balance. Of course, we can go ahead and we have put a number of years associated with that state of balance. And we put, actually, our sun will be main sequence. I'll put MS for main sequence star for 10 billion years. I'll put MS for main sequence star for 10 billion years. Very good. So this is just to kind of remind you that a bunch of stars And actually, when we talked about characteristics of stars, we said that color is no accident. The colors of the stars, remember we said that the blue stars are the more massive stars. They're hotter. The red stars are the less massive. They're cooler. A bunch of stars at different masses can be born at the same time in a cluster of stars. Generally called a cluster of stars. So one of the things that the video that we just watched said is that even though stars like Sirius and stars like Vega and stars like, stars in the summer triangle catch our eye, they're beautiful, they're brilliant, okay, they are actually more rare compared to their smaller counterpart. Okay, those smaller red stars, the M-type stars, are more abundant. We just don't see them. Our eyes don't pick them up. Well, that's a good place to end it, and so we will pick up here on Wednesday.